Alright, College Algebra, here we are again. In Chapter 1, Section 5, we'll be looking at applications and modeling with quadratic equations. Here are a few things that we'll be looking at. A geometry problem and using the Pythagorean theorem, height of a projectile object, and modeling with quadratic equations. So here we go. Alright, so our first example is our geometry example, and it's a problem involving volume. Here it goes. A box with volume 7,500 cubic centimeters is to be formed from a sheet of metal whose length is twice the width. Equal size squares measuring 10 centimeters on each side are to be cut from the corners of the metal sheet in order to form a box. What are the dimensions of the original piece of metal? So what we're going to do first is assign some variables. I'm going to call my original width, because in this question we are asked to find the original dimensions of this piece of metal. I'm going to say the original width, let that be x. And then our original length, we're going to let that be 2x, because in this problem up here it says the length is twice the width. Next, I'm going to draw a picture of what this looks like just to get us a better view of what we're going to be doing when we form our equation. So here is our sheet of metal. The length right here is 2x. The width is x. And then we are going to cut 10 centimeter squares from each corner. So I'm going to draw those in. And this dotted line is going to be our folding line whenever we make our box too. Each square that you see in all four corners here are going to be 10 by 10. I'm going to go ahead and write that in too. 10 by 10. And so now if we cut 10 centimeters from each corner there, and we're going to fold all sides of our box up, what we end up with on the inside here, this line right here and this line, our length and our width changes by a total of it's going to subtract 10 on this side and 10 on the inside, so a total of 20 centimeters we're going to subtract from the length and then the width also. So let's write that in. Here we have for the length, it's going to be 2x minus 20. And then the width is also, it's x minus 20. Okay, so I'll just call it our new width is equal to x minus 20. And our new length, is the 2x minus 20. Now let's form our equation. It's from the beginning we are given the volume of this box, so we're going to utilize that in our formula. And how we're going to do that is, well, we know the volume is 7,500 cubic centimeters, and to find a volume of a box, well, that's just length times width times height. Let's write that. Volume is length times width times height. Well, if we cut out all the corners and fold all sides up, that's going to be using these as our length and our width in our formula here. And then also the height, well, the height of the box when we fold these sides up, it's going to end up being 10. So we know the height also. So now we have volume. Well, that comes from up here. And that's equal to our new length, our new width, and our height. And there's our equation, and we're going to be solving for x on the next slide. Okay, let's go ahead and rewrite that formula. X minus 20 and 10. Okay, so the next step to be able to solve for x here is to multiply everything out. So we're going to end up having to FOIL it and then distribute it by that 10 that's on that far right. So FOIL the 2x minus 20 and the x minus 20. And then multiply everything by 10, and this is what we should get. 20x squared minus 600x plus 4,000. All right, so now we have a quadratic equation here, and normally quadratic equations, the first thing that we need to do, other than FOILing everything out, is to set this thing equal to 0. Right now it's set equal to 7,500. So subtract the 7,500 on both sides of the equation, so we can say this side is 0. And when we subtract the 7,500 from the 4,000, what we end up getting is 3,500. And now I'm going to say, let's simplify this a little bit. I think we can divide, we can divide everything by 20. And when we do that, it's still equal to 0 on this side, because 0 divided by 20 is still 0. Divide by 20 in the first term, we get x squared. Divide 600 by 20, get 30x. And 3,500 divided by 20, 175. Now, this right here is factorable, but we could use the quadratic formula on this if we want to. But I see that it is factorable. So let's go ahead and factor it. The two factors of 175 that add up to 30, or negative 30, is going to be negative 35 and 5. Okay, so now using that 0 property, we're going to set each set of parentheses equal to 0 and solve for our x values. Let's see. Okay, so now we have x equals negative 5 or x equals 35. Well, I'm going to say let's reject that x is equal to negative 5 because we cannot have a negative width or a negative length. So let's get rid of that. And let's say x is equal to 35. Well, that makes more sense because it is a positive number. And so the dimensions of the metal piece, the original piece that we are given at the beginning of the problem, we said that let the original width be equal to x. Well, x is 35 is what we just found, and that's in centimeters. And then our original length, was 2x, so multiply 35 by 2, we get 70 centimeters. And there we go. We found the original dimensions of our metal sheet. Okay, our next example is going to require us to use the Pythagorean theorem. So a couple of things before we start that. In a right triangle, we have the two sides that make up the right angle, so leg A and leg B. Well, those are called legs, okay? And then the longest side on our right triangle, this right here, and the one that is opposite of the hypotenuse, meaning this right here, it's opposite of the right angle, that is our hypotenuse. So just to let you know, legs and hypotenuse, where they're at on our right triangle. And here is our Pythagorean theorem. We're going to call one leg our A, and the second leg our B, and then the hypotenuse, that's always going to be C. So here's the Pythagorean theorem. A squared plus B squared equals C squared. So here's our example using the Pythagorean theorem. A piece of property is in the shape of a right triangle. The longer leg is 10 meters shorter than twice the length of the shorter leg, and the hypotenuse is 20 meters longer than the longer leg. Find the lengths of all the sides of the property. Okay, so again, let's assign the legs of the triangle the different values that we know them to be according to the problem. And go ahead and draw the right triangle. So first thing, it talks about the shorter leg, and it doesn't give a dimension on it. It just mentions that the longer leg is 10 meters shorter than twice the length of the shorter leg. So let's go ahead and call the shorter leg X. Okay, and then the longer leg, so the shorter leg is right here, and then the longer leg, we're going to say, it said the longer leg is 10 meters shorter than twice the length of the shorter leg. So twice the length of the shorter leg and 10 meters shorter, so minus 10. And then for the hypotenuse, it says the hypotenuse is 20 meters longer than the longer leg. So we're going to just take the longer leg that we have here, the 2x minus 10, and add 20 to it. So let's see, 2x minus 10 plus 20, which ends up giving us 2x plus 10. So here we have it. This is our sides of our triangle. And this is where we're going to use that Pythagorean theorem in order to help us figure out what x is and then find all the lengths of the sides of the property. Okay, so let's form our equation. Our equation is going to look something like this. Since this is, we're going to call it our A, this is our B, and this is our C, and our Pythagorean theorem states A squared plus B squared equals C squared. Plug in all your values for your A, B, and C to get our equation. So let's do that on this next slide. Alright, so let me write that A, B, and C out again. So A, let's get the pen. A equals x, B equals 2x minus 10, and C equals 2x plus 10. And our Pythagorean theorem is A squared plus B squared equals C squared. So plug everything in, a, b, and c. A is x squared, b is our 2x minus 10, all squared, and same thing with c, 2x plus 10, all squared. Now our next step in this, in order to solve for our x value, is to square the binomials that we have. So square this and square this. Multiply it out. Foil it if you have to. But here's what I'm going to do. So x squared, that stays the same. And then we get 4x squared minus 40 x plus 10, or sorry, plus 100. And that's equal to 4x squared plus 40 x plus 100. Alright, now get everything on one side, and so we can set this equation equal to 0. And combine like terms, of course. Oh, sorry, this was supposed to be squared right here. So once we combine like terms and get everything on one side and set this equation equal to 0, here's what we get. X squared minus 80x equals 0. This here is pretty easy to factor actually. Just factor out an x. And we have our solutions to this is x equals 0 or x minus 80 equals 0. So x is equal to 80. Alright, just because we got x is equal to 80 doesn't mean we stop here. What we were asked to find from the beginning was all the side lengths of our property, which are right here actually. A, B, and C are all the side lengths. Now that we have x equals 80, we just need to plug in 80 for all of our x values in our A, B, and C, and that is going to end up giving us all of our lengths for our property. So let's go ahead and do that. So if we plug in, well, this one's easy actually to find, the first one. Our side length A is going to be 80. And I forget the measurements. Let's see. It was in meters. So meters. B, if we plug in x for our 2, and it's going to be 2 times 80 minus 10. That's going to give us 150 meters. And then for C, it's going to be 2 times 80 plus 10. So that's going to give us 170 meters. And there's the dimensions of our property. Our last example is going to deal with height of a projected object. And a few things that we need to look at before we get into the problem are what I have on this slide here. It says we're going to neglect the fact that there's air resistance in these problems. And then the height is going to be denoted by S. And for this formula here, the measurement is going to be in feet. But our example uses this formula right here, which S, our height, is going to be in meters. So let's see. A couple other things that you need to know is that the initial height is denoted by the S sub 0, and the initial velocity, that might be stated in your problem, is denoted by the V0. That's what's going to go in this place, and your height, your initial height, is going to go in this spot here. So if it says it starts from the ground, then your initial height is going to be 0. And let's see, anything else? I think that's it. So let's move on to our example. Alright, so here's our example. If a projectile is shot upward from the ground with an initial velocity of 73.5 meters per second, neglecting air resistance, its height in meters above the ground, t seconds after the projection, is given by this formula that we have here. So, part A, what we're asked to look for is after how many seconds will the projectile be 100 meters above the ground? Well, height is being modeled by S. So what we need to do is plug in what we have, 100 meters, in for S, and solve for T. And that is going to give us how many seconds the projectile, how many seconds have passed for that projectile to be 100 meters above the ground. So let's do that. I'm going to replace our S with 100. And this right here is going to be our equation that we solve. So on the next slide, I'm going to rewrite this, and we're going to be solving for T. Okay, 4.9 T squared. Alright, so again we have a quadratic equation, and we're going to set this equal to 0 by subtracting 100 from both sides of the equation. Oh, that's supposed to be 4.9. Okay, this equation is not a factorable quadratic. So what we're going to be doing to solve for a value of t is using the quadratic formula. So here we go. I'm going to go ahead and write down that quadratic formula too. So t is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And our values for a, b, and c are going to be this here. A is our negative 4.9. B is 73.5. And C is the negative 100. Okay, plug all of those values in, and here's what we get. Let's see, negative 73.5 plus or minus square root of 73.5 squared minus 4 A C all over 2 A. Alright, so whenever we reduce what's under the radical here, this is what we end up getting. And there's a couple other steps involved whenever I'm reducing this. We get this 3,442.25 and over 9.8. Now, the next step is to approximate these two values that we have, because right here we have a plus and a minus sign. We're going to go through it once and say 73.5 plus the square root of this number divided by 9.8, and then go through it a second time and do the minus. And here's what we get our two values to be: 1.51 or 13.49. Now we ended up with two solutions that are both positive. If you think about it, whenever we throw a projectile up, what's going to happen is it's going to have a graph that looks something like this, and when it reaches a feet of, or meters of 100, it's going to go past the 100 mark, hit it once, and then come back down at that 100 mark again. And that's why we ended up with two different times. So at 1.51 seconds and 13.49 seconds, we have two solutions. So the projectile will be 100 meters above the ground after those two values that we just found. Our next part of this problem is going to ask us this: how long will it take for the projectile to return to the ground? So whenever it returns to the ground, which it started out from the ground, is what it said in the problem. So what we're going to be looking for is when it comes back to the ground. So when it hits the ground, it's a height of 0 meters. So S, in this case, S is equal to 0. So this is what we are solving. The equation that we were given from the beginning, S equals, so 0 equals our negative 4.9 t squared plus our 73.5 t. And here what we're going to do is solve this for t, and that is going to represent the times that our projectile was at the ground to begin with, and then when it fell back to the ground. Let's solve. Here it's actually pretty easily factored. You can just take out a t, and we're left with 4.9 t plus 73.5. And our two solutions, t equals 0, since the t equals 0 represents the start time, that makes sense. Or we have this little equation to solve. So 4.9t plus 73.5 equals 0. Solve this for t, and this is what we get. T equals 15. So 15 is our solution for this one. So it takes 15 seconds for the projectile to return back to the ground. And that is our solution. And that is the last example I actually have for you. So I'll see you in class, and you can hear me next time on the next video.